Okay, so in the previous clip, we introduced the concept of the mole, and we started to look at carbon and magnesium atoms specifically. And what we established was that if we wanted to compare some values and compare the number of atoms that we would have within a sample, then we would have to use the mass number and measure out, in carbon's case, or carbon 12's case, 12 grams of carbon atoms, 12 grams of carbon powder, and that will give us a set number of atoms. We compared that with magnesium and established that we would have to weigh out 24 grams. So coincidentally, we'd have to weigh out twice as much. But in terms of actual number of countable atoms, they would have an identical number. Now, if you've got an element, that's relatively straightforward because you just use up the mass number. But if we were to then look at, say, a compound, so if we go to magnesium sulfide, for example, we should have a formula of MgS, how do we know how much of magnesium sulfide to weigh out so I have a comparable number of particles within that substance? So in order to do that, in terms of magnesium sulfide, what I'd have to do is look at the two individual components. So this is where we need to have confidence in formulae, valency, and subsequently, as we move forward, balancing equations as well. But magnesium is made up of a magnesium ion, magnesium 2 plus. We ignore the loss or gain of electrons because we know that their mass is relatively small. And we know it's got one sulfur, it'll be a sulfur ion, 2 minus ion, but again, we ignore the relevance of the electrons for the purposes of mass. And magnesium, as we've already established, is 24, sulfur is 32. And so what we do is we simply add those numbers together. So magnesium has a mass of 24, sulfur has a mass of 32. The combination of those two values gives us a mass for magnesium sulfide of 56 grams. So if I were to weigh out 56 grams of magnesium sulfide, that would have the same number of magnesium sulfide particles, they're ions, but in terms of magnesium sulfide entities, it would have the same number of particles within it as the 24 grams of magnesium started life as, or if we were comparing to 12 grams of carbon. 56 grams of magnesium sulfide would have 1 mole of magnesium sulfide particles within it. Okay, and that's very important. This is where we can then compare these values, because what we would then move towards is knowing, and the reason why we do this is if we were to look at an equation, and this is why the mole comes in, magnesium plus sulfur, it's a direct combination reaction, produces magnesium sulfide. And what this is telling us from balanced equations is one of those reacts with one of those and one of those. And this is what these numbers are. This is telling us that 1 mole of magnesium will react with 1 mole of sulfur and produce 1 mole of magnesium sulfide. And this is why we have to balance equations. The numbers in a balanced equation are representing the relative ratios of the atoms, molecules, particles within an equation, and that relative ratio is the concept of the mole. And when we're looking at compounds, we're looking at something which is an addition of the mass numbers. Okay, now this would have a specific concept, and this value of 56 is something called the relative formula mass. Now, depending on textbooks and which versions of web pages you use, you can see different versions of this, but this is the relative formula mass, and it's the mass of the formula. Okay, the relative formula mass. You see other versions, relative molecular mass, and things like that, but ultimately it means what is the mass of 1 mole of the substance we're looking at, and you do that by adding up the individual components.